So today I would like to discuss about server security. I'll be covering firewall and another thing called IP tables. The two features. We'll see both of them. Okay, so coming to computer security, so they normally call as a three-tiered model, which assesses risks of the sensitive information and establishing security policy. The standard security model involves three things: confidentiality, integrity, availability. Confidentiality actually means make sure the information is available only to the predefined individuals. And the integrity is basically is something which the information should be unaltered, should be made sure that the information is not changed by any unauthorized users, and availability is should be accessible to all authorized users anytime that is needed. So these are three things people make sure when we come to computer security. Of course, there are more things are coming up, more things are being developed these days for taking care of the low-level cryptographic algorithms like ciphers, hashes, and message authentication codes for at various levels that takes care of addressing the security concerns. So security control may have to be done in three levels. One is physical, taking care of the entry into the data center and things like that. That's one. The other one is the technical one. So this is what we are going to see. And the third one is the administrative one. So all of our team members have to be trained with the required knowledge to handle the systems. So we will be focusing more on the technical part now. So first thing we are going to discuss is we are going to see is interaction firewall. So this is the thing that we are going to see. So most firewall is way to protect machines from unwanted traffic from outside. It enables users to control incoming network traffic on host machines by defining a set of firewall rules. These rules are used to sort the incoming traffic and either block it or allow through. So if you see the picture at the right, so the packets that are the information that are coming from the internet may will go through a component called firewall before reaching our enterprise network. And this firewall has the rules, predefined rules, configured to make sure only the genuine packets are being sent and all other things are dropped. Okay, so the firewall rules basically are written in three ways. One is from where the source is coming from, and what is the objective of the packet that is coming, and what is the substance inside it. So based on these information, these rules are written. If you see the firewalls, there are many types of firewalls. So we have a stateful firewall, packet filtering firewall, next generation firewall, this is a new thing. NAT firewall, proxy firewall, web application firewall, SMLI firewalls. So so many firewalls are there. So at various levels. I mean, people prefer using these firewalls depending on their requirement. So we'll be seeing the packet filtering firewalls now. So as I had mentioned, so firewall, we will have to write policies. And these policies will have rules. So these are the policies. Then we have to write rules. And these rules will involve identification of the incoming packet. Based on that, he will take an action. So that's what the thing is. The action is basically can be directed to zones. So the firewalls are basically written based on zones and services. So zones is basically we have so many zones here. There are zones which are available for block, DMZ, drop, external, home, internal, public, trusted, default. By default, we'll have the public. Public is what is the default zone, which would be taken into consideration in case if we do not give any specific zone, no mention about zone, it will take it as a public. So these zones are basically the zones that are, so the systems that are inside an enterprise network are considered private, and hence they will be called as a trusted zone, and the public ones or the ones that are open or it is available for the internet. So maybe it's from the public domain, and we have other things called block, where we can assign a policy and move every rule to the zone which is in the block state. So likewise, these zones are there which we can make use of while writing the policies. So for example, a zone can also have some resources assigned to it. So if you see here, we can assign a resource, which is interface, Ethernet interface is being assigned. And we can say that this zone can have this service which is available, service which is allowed. And we can also say that this port number 80 is also allowed. So likewise, we can create policies. If we see firewall daemon, so there's a firewall daemon which is running in the CentOS. So if you see the firewall daemon, so there are two entities that are there. One is firewall daemon, and the other one is the IP tables. So these two things takes care of securing this server. And if you see here in this picture, so this there's a net filter, kernel net filter, which is there at the bottom. This one. So the kernel net filter is what is being used, which is there in the system. Both of these services uses this kernel net filter in effect. But so both these two things work in little different way, and we have some advantages and disadvantages. People sometimes use both also. Okay, so firewall uses, as I had mentioned, it uses zones and services. Zones are nothing but predefined set of rules. Resource also can be assigned, like network interfaces can be assigned to a specific zone. So there are various zones. So some zones allow all traffic by default, and that's called a trusted zone, public zones, where you do not trust other computers on the network. So services are nothing but the predefined rules that use one or more ports or addresses to filter traffic on the network communication. So is what is called what is the services they as the terminology per se. Assigning interfaces to zone with firewall config tool can be done. Can also be done using the firewall command as well. Okay. So function wise, we have when you see firewall daemon, so we have a configuration tool like firewall config. There's a firewall config tool, and there's a firewall command tool, which we can use to configure the firewall daemon, which will in turn use the net filter, which is there as part of the kernel, to do the required filtering. Same as that, so we'll have IP tables. There's a configuration command for IP tables here, and then we can use that command to configure the IP tables. In turn, it will configure the net filter to do the job for us. Okay, so few firewall commands.
Let's just one question. If you go back to the slide previously, so now we are on the right side table. You are saying system config firewall, and we are saying firewall config. What is the difference with this?
firewall config, this is very specific to firewall. So these IP tables are also, IP tables is also called as command line firewall. That's why it is called as the system config firewall. So it's also called as a firewall. So that's the reason it is called as system config firewall. But firewall config, both firewall config and system config firewall are two different things. It's not the same. The firewall config is very specific for the firewall. System config firewall is very specific for the IP tables. And the functionality wise, it's different because they configure different services.
Okay, but for normally, if you take a server, so any server, which is the main file. So in general, we are referring to IP tables command. So how we control these two firewalls, and what is and which firewall we use for what? So for the server at server level, hardware level, which service can talk to this server using which port or which I don't know, like communication. We defined it in IP tables, or let's say in the firewall config table. I mean, just to understand the main difference between these two and how we can use it at the server level.
Yeah, so one difference that I, as per my knowledge, is basically there are some, we cannot say this is best and that is not best, but firewall as such, we have a overall level control. We have zones and we have services and ports. We can also do whatever we can do it in IP tables, can also be done with a firewall. But if you want to change anything in the IP table, we may have to rewrite the rule. So that's what the Red Hat documentation says. There are two differences they say. So firewall service, there is a D bus that they are saying. So this D bus thing, so which is actually dynamically apply the rules. So it will dynamically apply the rules instead of instead of rewriting the rules. It will remove the, so debuses dynamically, it will apply the rules. So it has the ability to do that, but IP table will not have such things. We may have to remove the one and then we may have to rewrite the thing. Something like that is said.
Okay.
Yeah. Okay, so a few firewall commands. These firewall commands can be written as runtime, and as we can also make sure configure this as a permanent configuration. So for permanent configuration, we may have to do like -hyphen permanent. So this will make the configuration permanent. And reload after permanent, we may have to reload the configuration. So that will reload the firewall service so that the configuration that we have made will be applied permanently. And if you want to make a temporary configuration, you can say runtime to permanent. And so this will not make it permanent. So we can make the configuration and then we can leave it, and we can leave it like that. So it will go off. So which means the next reload, it will not be there. So if you do it, if you want to have it as a permanent, it will be, we may have to give -hyphen permanent. Okay, and we can also have the service enabled on a time level basis as well. So if you see here, there's a time out which we can configure like 15 minutes to allow the SSH service. So like this also we can configure based on the time level, timeout. To add a service, we may have to give the configuration parameter add -add service. And if you want to add a port, we may have to give -add port. And port we may have to specify the TCP or UDP. And to view the services, we may have to give list services. So it will list down the services that we have configured, list down the ports we want to give, can give list ports, and if you want to give all, so if you can see list -all. So firewall, we can disable also, we can enable, and can have it started and stopped by means of CLI commands. So some real-time useful firewall commands I've just picked up and I put it here. So firewall is capable of doing the port translation. Port translation, the first one is port redirection, what is called. So if you want to have a port, the incoming packet is coming in port number 80, which we want to translate to port number 20, port number 88. So we can have this firewall return so that it translates the incoming packet coming with port number 80 to port number 88 when it comes to the internal network. And same way, we can add another rule to configure it back. If the packet coming from 88, we can change it to 80 when it goes back to the public network. So this kind of application we can have, which is useful for port address translation. The next one is in case if you want to block an ICMP packet. So
sorry, Alex, for the first one, what you're saying to redirect port, we are adding port forward from port 80
to port 88. Port 88.
Okay. That means whatever the traffic comes to port, it will divert to 88. This is like temporary.
Right. Temporary, because it's like a port address translation, like it's like a network address translation. There is a port address translation. So from the public network, if you get if you want to direct, while we are getting a packet from the public network, we can have another server. If it is port 80 is maybe a HTTP server, we can have our own HTTP server running on port number 88. So that will, when it comes to our internal network, it will go into this web service, so server, which is running in port number 88, something like that.
So that is clear, but will there be any benefit or difference? Because normally port 80 is just open. So what we are applying any filter or like between port 80 to port 88, are we doing any checking internally as kind of HTTPS checking or any other?
No. This is for the security concern. So there is a zone called DMZ, demilitarized zone, which is some of the servers may be available for the public people to use, but these servers would be inside as part of our internal network. So in such scenarios, they will use this port address translation.
Okay, so for the source, it will be 80, but for us, destination, it will be different.
Correct.
88.
88, yes.
Okay.
Yeah, that's correct.
And so it will be the same going outside? It can be the same going outside?
No. So because outside will be it doesn't matter, I think. So port when the packet comes inside is what is matters. When it goes outside, they should not matter, because based on the it should go back with the same port number. So that port address translation should happen at the reverse in the reverse direction when it goes out, so that then only the packet will reach the exact source which the packet came from. So it will do the reverse part of it. Then we will have to configure that as well in the firewall like this.
Also, separate configuration for this, like
we may
add
have to
forward. It should be like what? Add forward.
Yeah. So there is a configuration. So this is not a preferable configuration because having a public server within our internal network is not an advisable thing because we will have to manage with all sorts of attacks. So normally we have this thing at the public itself, and we have our internal network protected. So that's what at least people are moving to cloud, and nobody like to have the public server inside our inside network. But for reference, I am having. But firewall is having a DMZ zone. So I said like there are zones available. So firewall has got a zone called DMZ, demilitarized zone. So this has this feature to configure. We have this feature to configure this thing, and we can configure it into the demilitarized zone, where we can assign the IP addresses and the servers which are belonging to the public network. Okay, and there are a few more things. So we can have firewall command to block any echo request. So like ICMP ICMP block is equal to echo request. That will block the ICMP echo request entering into the system, and we can remove it also. And there's another command which is how we can also say is that from packet coming from this source should be going into the zone block. So which actually means the source addresses assigned to the block zone will not get will be dropped. So this we can do it. I can demonstrate this also.
Yeah. Yes, okay.
I have two nodes, VM1, 2. So this is 15012. This is the IP, and this IP is 15011. So this one is 12. So in here, so I'm going to configure this one, saying that add source, the packet coming from this source should be kept under blocked zone. And I'm not doing it in permanently, so you can see this configuration, whatever I've done by list all zones. So if you see here, there's a block zone here, and the IP address 172.15.0.12 is got configured here. So what does it mean? So this means the packet, if whatever comes from here, 172.15.0.11. So if I'm trying to ping, so it says packet filtered. So I'm not getting a successful response. Instead, it says packet filtered. That is because.
So just one question, because you see this firewall dash command. This is the default bash or default command because when I'm trying to use this one, firewall dash command, it's saying command not found. Is there any specific reason for this?
No, I don't think so. May have to make sure firewall is running or not. Firewall D.
Oh, the service has to be running.
Firewall D, if it is running or not. By default, it will be running. If it is CentOS, it will be running. Maybe if it is disabled for some reason, maybe.
Yeah, I don't find this strange. I don't find this firewall service
running. Firewall service itself, right? Firewall D. System status firewall D.
Yeah, uniformity could not be found. Strange. So you don't find this firewall this service. Maybe IP table is different than firewall.
Yes, IP tables are different. Again, you can check IP tables as well.
Yeah. So ideally, it's like something we cannot use both, or it has to be one only.
No, can be used. We can use both. In my
Yeah.
system, I
So
have both. The IP
yeah. So
tables
IP
minus
table.
L.
Okay. We are using IP tables. Yes.
Oh, you have IP tables. Okay.
Yes.
Maybe thing is they as a corporate people would decide whether to align with firewall or because that could be we might have some conflicting rules we should not get into. So firewall is allowing, whereas IP tables is denying things like that. So maybe they would have taken a corporate decision.
Okay. But anyways, IP table else will list you all what is chain forward. But now when you're applying firewall D, it is going to firewall D, not IP tables. That's why I was
No,
trying to
no.
understand is there any difference for this or
Yeah, both are different. So firewall configuration rules will not get into IP table configuration. So
okay.
it will be only with the firewall rule. But inside the kernel, so all are taken care at the uh, what is it? Kernel filter, net filter. So because it has to be done with only one TCP stack is there. So so all things which should have get configured only in that stack.
So but for IP
So
tables now, if I want to see the current rules, what is the
yeah,
command
IP
for
tables
this?
minus L
Yeah,
list.
but it will give me
Capital.
the ports which are allowed or not allowed. But it's not giving me.
Yes. Yeah, IP tables minus capital L.
Yeah, I listed this one. Except Docker exception. Okay. Okay, this is the only one. Just want to see if what ports are allowed. Any specific ports are allowed, not allowed. But
Yeah,
it's
you
giving
can.
target port TCP UDP. Just saying TCP UDP anywhere to anywhere.
Anywhere to anywhere means, I mean,
Yeah.
it doesn't matter, like source and destination doesn't matter.
Okay. Okay.
So,
Yeah. No problem.
yeah, we'll take a look in the IP table configuration, so you'll get to know some things. So
No
likewise,
problem.
that's all about firewall. Um, so we'll go to IP tables. IP tables is also called as command line firewall. If you see IP tables are architected. Again, these are also based on rules, but these rules are have to be configured in chains, and we have these chains are present under tables. So if you see the picture, this is how it is being designed. So
Ah,
there
so this is how.
are
Oh, okay. So the rules in the chain, then chain. Okay. Okay.
yeah, so there are 5 types of chains, and each chain will have rules inside it. And 5 types of
Oh,
chains are there. There's a pre-routing chain, input chain, forward chain, like this.
so this is like a fixed type of chains. Pre-routing,
Yes.
input, forward, output, and post-routing.
Yeah.
Okay. I mean, okay. So we have a
And we
choice to
have
use any of this. Okay.
yes. I'll tell in the next slide. So before that, there are again 5 tables are there. That's well. Filter, NAT, Mangle, raw, and security.
Okay, they're defined by table, chains, and rules. So chains are
Yeah.
grouped by rules, and all. So rules are grouped by chain. Then chains is grouped by tables. This one is
Correct. Yes,
okay.
that's correct.
Okay. Next. Okay,
Okay.
continue.
So if you see, I told like there are 5 types of 5 chains: input, forward, output,
Okay.
pre-routing, post-routing. So this actually means when the packet comes in, so it will have to before getting into the routing decision, we can apply the rules inside the incoming chain. It's called the so sorry. So that's we can apply rules on the pre-routing chain. So this is the pre-routing chain. Inside here we can have our pre-routing chain. Just after routing, the packet may go to another destination, or it might be consumed inside the server. If it is consumed by the local process, then we can apply this input chain. And if it is going to get forwarded to another system, so we can raise another chain in the forward, we can apply the rules in that place as well. And so, after before getting out or just before going out of the system, so there's another chain called post routing chain. So we can apply rules over there as well. And there's an output chain in case if there is a packet that is initiated by the server from the server. So that will also be applied under the output chain. So we can have rules applied under the output chain. So likewise, we can have rules applied in different chains, and any point of time, like one packet might undergo different rules in different chains. So it might initial time it might have go through pre-routing, forward, and post routing. It may go into all of these rules and get applied, and then it comes back. But so I don't think firewall has this ability to do this. So this is in a way like it's like a pipeline.
We can have the rules at pre-routing and post routing.
And forward.
And forward also. Okay.
Yeah, forward also. One packet can undergo rules in the forwarding and pre-routing and yeah, so post routing also. So all three, it can go through pre-routing, forward, and post routing. It can go through the rules applied rules that are applied for that specific packet. If we have a specific packet and saying that this source, this destination, or this port, and we have a rule at we can have a rule at pre-routing, we can have a rule at forwarding, we can have a rule at post routing. So same packet which is identified by the same matching criteria will undergo the rules in different chains before getting out of the system. Make sense?
Yeah.
Yeah. Okay, so IP tables command. It says IP tables, and then it's a CLI command. It's a terminal command that we can have to give IP table, and then we have to say -t, give the filter name, sorry, table name. The table can be mangle table, map table, filter table, all that. And then we have the option A for append, L for listing, F for flushing all the rules on a chain, and D for removing a particular rule. So all these options we can have. And then we can chain name, we can define here which chain we mean here. So forward or input or output, all that you can give. And then comes the matching criteria. The matching criteria, we can say which matching criteria that we mean here. So we have the option to identify a packet through destination IP, then destination port, ICMP type, protocol, source IP, source port. So we have different ways to identify a specific packet. And then finally, we have the action, which is the target action. This could be accept, drop, or reject, and we can also have a log. There's also have a target as a log where we can specify this packet which has come to the system at this particular point of time. So whatever we have, so we can give it in that log. So some IP table command examples. IP tables -L will list down all the rules. And if we have, if we want to filter any packet, we can, or if we want to drop all sorts of packets coming from any site. So this command we can give IP table -T filter, and then say that it's an input chain and not specifying any matching criteria. I'm just saying drop all. So this will drop all the packets. So, and it will actually will not allow even the SSH connections. And if you want to remove the rule that we have written, you can give the input, and this is only one rule. You can say that can be removed. And likewise, we can have other information like source IP, and we can also say like this thing we may have to write in the log file. So like this we can create. Maybe I'll show one example.
Today, but if we can start with, like, for example, before we make any changes, as a normal step, it will be like to see what is there in the system today. So how we can check this one?
Yeah, just to if you want to see the firewall, so firewall
No, IP tables, yeah.
IP tables, IP
Yes.
tables minus L. This will list down all the rules. Currently, it is showing. In my case, by default, it is showing input chain, forward chain, and output chain. So these are the three chains which are available by default.
Okay. Okay.
Because my system is not configured for routing, so all the routing, pre-routing, post-routing things are not shown here. Okay, so if
we can create like a custom chain also, like
yes, we can create custom chains as well. So if you want to create a custom chain, for example, minus n, let's say so I'm just creating with my name. So chain Alex.
So now in this you will create a rule. So what to accept, what to reject, and so on. Okay.
Yeah, we can create a rule. So to remove it, minus X. Okay, so let me create a rule in the input chain to drop and drop all packets with the source IP 172.15.0.12 minus J drop. I have created a rule now. This rule says to drop all packets that are coming from this IP address. This IP address is my node 2 IP address. And let me see if my configured rule is present here. Yes, the configured rule is present here. So the target is drop all protocol packets coming from this source. This sent node 2.chosen.local. This is my second node. Going to anywhere, it doesn't matter like which location is going, but if it is coming from this thing, just go ahead and drop it. So that's a rule. And I'm now going to give the same ping command, and it's not going because of this rule. And my ping is not getting succeeded because this rule is present. Let me now remove this rule, the input 1. So when I give this this command, it will remove the rule, and now there's another rule that is there, packet filter. So I think that's because of the firewall. Yeah, so now it is going fine.
Oh, so because when you ping it, it will say you filtered.
Yeah, ping. Yeah, previously when it was filtered by firewall, it was saying it is packet filtered.
This is how you will see it. This is normal.
Normally we get the 64 bytes, no?
Yeah, this is normal. But you know, when if it is filtered or blocked by firewall. What is the way to see it? Normally we go to TCP networks and so on, and our resources in Windows. But where we go here?
So here there's another option to log. So by minus J, and instead of accept drop, we can also have it logged. So this actually, you see here, so it's taking as a warning. So the packet that is coming from this node, it's taken inside, but still it gives a warning in the log file, and that's how it is configured right now. And if you see, I'm going to initiate the ping now. Ping is going on. This this person will actually have these things in the log file. So tail var log messages. You can see it's getting logged here. So we can, while we are having the log, while we are configuring the log file, we can specify the prefix also, so that it's easy for us to remember. So, or filter from the logs. So we can say hyphen log prefix, something like that we can give. So hyphen log prefix. The two rules got written here. Let me remove the one. Okay, so what is this?
Okay.
I'm initiating the ping, and if you see, and you can see the log, which is with this stick, Alex testing. So this is the prefix that I gave, and says that he has received a packet, and that's still accepted, and it is taken inside.
Okay.
I think in case if you do not want to accept it, just want to log it, I think we can add another rule. One rule to log, another rule to drop.
For me, I just want to see in real time. Let's say, okay, now you apply these rules. Okay. So now you're trying to use it. But instead of logging it, is there any way or a let's say interface or command level that I can see in real time, similar to logs, let's say, that okay, the request is coming to the server, however is being blocked by rule. Or for example, the specific port is not open in our server, the request is coming. Let's say port 80, the request is coming, or port 443, the request is coming, but we are blocking it. We are receiving it, but it's blocked by firewall rule. How we can check this? In the IP table logs only, or in the command line we can check somewhere?
I don't think we have a command line to do this. So only thing is we have the logs. Other than that, not sure. I don't think we have any support to
like normally
dynamically
you do
show.
like TCP dump, for example, in real time it will show you what is the traffic that is coming and so on and so on. Correct. In TCP dump.
Correct, but the TCP dump is on a dynamic thing, so that will take it will consume a lot of. I mean, we cannot have this open. We will not be able to watch it as and when it comes. So we can have something. We can write a script maybe to post something like that, trigger something like that. We may
really?
Yeah.
For example, to compare this one, I will give you exact comparison. I will try to give it. Let's say if you take a Windows on Task Manager, you have a resource monitoring. So on the resource monitoring, you will have multiple options, including the listening traffic, listening ports, and so on. So there you will see, okay, what are the services running, and these services are working with this port 5389, for example. And then the status is blocked or is allowed, or for example, like this, right? You will have these details. So that details, similar details, how we can have it in CentOS?
No, that is, we have this top, no? So that is dynamically showing here in the screen. Can you see the screen now?
This is like a task manager, running processes and the IDs and so on, right?
Right.
So further to Windows, if you have like this will be at system level. Where is this one? Task manager. If you have Windows, can you bring up task manager for the Windows?
Yeah. Yes.
Yeah, I think under performance.
Okay.
You have no, the process. If you have process, where is it? My system is hanged wide. I don't know. Just 1 minute, please. If you can. Should be in performance. Yeah, in performance, you have on the right bar, right? There is a right bar, the 3 dots. You have resource monitoring. Yeah, performance on the right, top right.
Yeah.
Yeah, so resource monitoring. So now here, the window opens. So these details you have it, like storage, and you will have the listening ports also at the downside. I don't know if this is Windows 7 or what.
Windows 11.
Yeah, you will under network. If you switch to network on the right side, the about tab, yeah. So for example, here you see listening ports. You have TCP connections and details. So listening ports. If you expand listening port, please. So here you will have all the details like protocol, which protocol or which is firewall status allowed or not responding. You see the column there, firewall status. So this kind of details, if I want to see in Linux, how we can see it? This is in real time. I'm showing to you each port, each firewall status, and everything against the service.
Oh, okay. So, so I am not sure about this, so I'll get back. I'll check. Definitely, it should be there. If it's there in Windows, it should be there in the Linux
so exactly
as well.
this.
Maybe
We want to,
it could be the cockpit. One thing is there. There is a web min is there.
Okay.
There are things like which are there by default in the server, which gives us different monitoring things, monitoring tools. There is a cockpit. Do you use any of this in your office?
The
There's a
cockpit,
thing called
the tool.
Yeah, cockpit tool, webmin.
I need to check what is installed here. Let's say just the service monitoring. No, maybe we can try it. I would say. So
it should be there.
Search. Yeah, because I don't know if it is a free tool or a paid tool. Cockpit,
no, cockpit is free.
It is available in the repository.
Cockpit is free. But we need to configure this.
Is the service monitoring tool or like what?
Yeah, it is a service monitoring tool.
And what the other one? What you say?
Webmin. WEBMIN.
WEB. It's not there in the repository. When I search. I can see cockpit. Version. Yes, I can see this.
Cockpit
web
is showing up.
Linux servers. This is the web console. What is shown?
Yeah, cockpit is there, right?
Yeah, cockpit is there.
Yeah, cockpit should be able to see. Maybe we may have to check. Not sure. Cockpit is installed already, right?
No, I will install now. So
It's
what is
there
that?
as part of default by default was there.
No, it is in the repository. It is there, but it's not installed by default. Cockpit version 8664. Okay, I will just try to install it. I mean, it requires a web console, or like we can run this in CLI mode.
No. It's a GUI thing. So this kind of things we want it in GUI, right? So I don't think we can just. It will not be good to display such things in the CLI.
CLI. Okay. Okay, clear, Alex.
Yeah.
Anything else you have for today?
No, that's all, Rafi. So
Okay.
done. Yeah.
Okay, then it was
Okay.
good, Alex. So tomorrow we can
Yeah.
continue.
Sure. Yeah.
Thank you very much.
Thank you.